Hello everyone. In this video, I'm going to talk more about how to make sure that your process is under statistical process control by drawing mean chart and R chart. Remember, we call mean chart as X chart, and we also call R chart as range chart as an R chart. Okay, so don't get confused with the terminology. In this video, what I'm going to do is I'm going to show you how to draw mean chart and R chart and how to conclude whether your process is under statistical process control over this service facility, which is a health center. And what we are given here is that a short problem description, and we do have the data set that we are going to be working on. So let's take a close look at what this problem tells us. All right, so let's assume that Florida Southern College Health and Wellness Center is committed to provide services for students, staff, faculty in meeting their acute health needs. The center here is concerned whether the wait times of patients in minutes below in this table is in statistical process control. The average wait time should be centered on 8 minutes per patient. Several samples of wait times of 8 patients are collected during different times of a day, and each wait time is measured in minutes. This is a typical setup of a problem in real life as well. So what you are given here in the problem description, an expected value or the expected or average wait time that you should encounter in real life. So we call this mu or mean, right? We are going to say that, hey, the expected wait time in this center is around 8 minutes. And what they did, they collected further samples to prove whether their process is in statistical process control or not. Let's call them a sample 1 through 6. So what we have here is we do have K, which is number of samples, okay? And that's equal to 6. So we do have I, that stands for sample I. We do have 6 different samples, but what do I have here as a sample size? Sample size would be the number of observations in each sample. Number of observations in each sample. In other words, we call this sample size. Okay, and our sample size in this problem is actually 8. Okay, so that's the first thing that I want you to do. If you're given this data, I want you to, a data like this, I want you to be able to understand how many samples you have, and in each sample, the total number of observations, which is the sample size. Okay, so let's assume that these averages are and the range values are given to us for the sake of this problem, but in the next video that I'm going to release, I'm going to show you how to calculate these averages and ranges in much more detail. Just as a short way of understanding where these values are coming from, the average values are just, for example, for sample 1, adding those up, right? Adding those wait times up and dividing the entire sum by 8. All right, and we will repeat this for sample 2, sample 3, sample 4, sample 5, and sample 6. Of course, I did that in Excel. You can do it in a calculator, but Excel is going to work just nicely. And for the range values, if you have taken stat, you know that what a range value is and how to calculate it. The way that we calculate range is very simple. For a specific sample, range value is just the max value in that sample minus the mean value in that sample. For sample 1, let's try to find the maximum value in this set. And if you focus on it, let's see, the max value is, I think, 8.44, and the minimum value should be 7.68, right? So if you take if you take 7.68 out of 8.44, you would end up with this number. Okay, so this is how you do it. for other samples too. So you look at the max value and the min value, and then you put the differences together, and then that will be your range value for each sample. We will need averages, sample averages. These are sample averages, right? And sample ranges, right? We will need this when we try to calculate our center line, our upper control limit, and our lower control limit in mean and R chart. Okay, so before I go further down with the solution, so I'm going to remind you what we have as a resource. If you look at your materials posted online, you will see that I posted this nice summary table. These are basically the list of rules or the steps that you are going to take to put together a mean chart here, and then the R chart, right? And we do have the steps here, depending on whether we do know the population standard deviation, sigma, steps are going to be different. And on the second page, I do give you table 6.1. Make sure that you know how to use this table, because there are some constants, A2, D2, D3, and D4 that you might need to use when putting those mean charts and R charts together. As you can see, this formulation, for example, is going to require you to use A2, and this formulation is going to require you to use D3 and D4. If you don't know where these values are coming from, you are just going to look them up from table 6.1. How do you look them up? Based on the sample size, remember n value, right? I showed you how to find this value. Based on the sample size, whether it is 2, 3, 4, 5, 6, 8, in our case, it's going to be 8. You are going to look them up directly from this table, okay? So this is just an introduction to putting mean chart and R chart together. So let's go back to the question and let's see how we handle this. Okay, so let's take a look at it one more time. Okay, we have the sample averages, we have the sample ranges, and as a shortcut, we use different terminology for sample averages, right? So we use this notation, X bar I, and we use our I for sample ranges. Okay, so remember the takeaway that we concluded in the previous video was to construct both mean chart and R chart so that we can conclude whether our process is under statistical process control. Both charts have to be under statistical process control so that we can claim that this process is under statistical process control. Okay. Okay, that was the warning. So let's start with the mean chart. Okay, how do we do that? So let's go back to the definitions or the guidelines. Step one for the mean chart is, let me zoom this in. Okay, so you can see nicely. So the step one is calculate the mean of each sample. That's what we did already, right? I mean, we assumed that we calculated already. I'm going to show you how to do it in Excel in the next video, but we already have these values. That's good. Number two is calculate the grand mean, X bar bar. X bar bar is going to be the average of the averages, right? We're going to use this to calculate the grand bar, okay? And step three, depending on whether you know the population standard deviation, you're going to follow step three and step four. If not, you're going to go to step five. In our case, let me show you the problem description one more time. In our case, we are not given any sigma value here. So sigma is definitely unknown. Therefore, we are going to skip step three and step four here, and we are going to jump in directly step five. In step five, we are going to be calculating R bar this time. It's going to be the average of the ranges that we found for each sample. We are going to take the averages of the ranges and we are going to use it as our sigma, standard deviation. If those terms and terminologies, sigmas, means, and ranges, they are not really familiar with, you're not familiar with them, you don't have to be familiar with them to be able to calculate the center line, upper control limit, and lower control limit. As long as you follow the notation, you will be able to do it. So if this is the first time you are hearing them, don't worry. Just bear with me, and then you will see how easy it is to find actually the center line, upper control limit, and lower control limit. All right, so this is our problem statement. We don't know our sigma yet, but we do have the sample averages. We do have the sample ranges, right? The first step was to calculate. Let's go to step 1 for mean chart. And I'm going to show you that the mean chart is to calculate the mean of each sample. We did that. Step 2 is calculate grand mean. So let me write it down. We have a check here. Step 2, calculate grand mean. How do we do that? Well, x bar is just going to be x1 bar. It is just adding these values up and dividing them by 6 because we do have 6 different samples. So it is going to be x1 bar plus x2 bar plus x3 bar plus x4 bar, x5 bar plus x6 bar, and dividing it by 6. So let's plug the values in. In this case, 8.04, 8.16 plus 8.16. Keep going. 7.94, 8.05. Two more. 8.05, 7.98 plus 8.13. And this whole thing divided by 6. All right. Let me quickly do the math here. I haven't calculated this yet, but it is 8.04 plus 8.16 plus 7.94, 8.05, 7.98, 13. The whole thing divided by 6. So our grand mean is equal to 8.05. Okay. All right, we are done with step 2. So let's go back to step 3. All right, what does it tell us? So step 3 tells us that if I do know population sigma, in this case, I do not know that. If I knew it, then I would just calculate the sigma x bar by dividing the sigma by square root of n. In this case, n is the sample size. In this case, it is 8. Square root of 8 is a fractional number. In this case, I don't know that. So the direction is for me to go to step 5. All right. In step 5, I will have to calculate the average of the ranges. All right, let's do that. All right, so here I will say sigma is unknown. Go to step 5. Okay, I'll go to step 5. Step 5 is telling me that I should calculate R bar. In this case, it is going to be R1 plus R2 plus R3 for 5 and R6 divided by 6. All right, what are those values? Let's figure it out. So those values are 0.7643, 3241. All right, two more. 0.33, 0.03. All right, and then divided by 6, because we are looking for R bar. All right, let's do the math. It should be 0.76 plus 0.43 plus. So I'm doing this manually, and hopefully I'm going to show you how to do this kind of things in Excel, and you will very much appreciate, I believe, how we can automate this in Excel platform. But this is fine too, because by this way you are going to understand the nitty-gritty of the processes. Okay, so we found that our bar is 0.38. Let me double check my calculations to see that I haven't done any miscalculation. So 0.32, 0.44. Yeah, I think it looks good. All right, let's go back. That's step 5, part A, I believe. Okay, so step 5, part A, I calculated my R bar, and then it says that now I can go ahead and calculate my center line. Center line, upper control limit, and lower control limit. Simple calculations. Okay, center limit is going to be directly equal to my grand mean, and my upper control limit is going to be equal to X bar, the grand mean, plus A2 times R bar. All right, so let me write those formulas down. By this is part A, right? Step 5, part A. Part B tells me that my center line is equal to my X bar. Now I do know this value. I calculated this value in step 2. It is 8.05. So 8.05 is my grand mean. My upper control limit is equal to X bar plus A2 value times my R bar, right? I do know X bar, that is 8.05, plus A2 value is something that I'm going to look up from table 6.1, but I do know my R bar value, and that is equal to 0.38. So let's look this up, okay? A2 value, let's look it up. Remember, in this cheat sheet on the second page, I gave you this table, and the A2 column here is on the second one. You do look at the sample size of 8 and directly look up this A2 value, and that is 0.373. Okay, and we can just say 0.373. All right, let's do the math and calculate this whole UCL value. Well, before we do that, I'm going to write down the formula for LCL. It is the grand mean plus, it's not plus, this time it is minus, the same value, A2 times R bar. So once you figure out those parameters, it is easy to calculate the rest. Okay, so let's calculate UCL and LCL. All right, open up calculator. So it's actually 8.05 plus 0.373 times 0.38. My upper control limit value is 8.19174. I'm just going to say that this is 8.19. And lower control limit, all you have to do is to change this plus to negative, right? And then that is I'm just going to include the 2 digits, 7.0 non-zero. Well, this is technically, if you round the second digit up, 7.91. Excuse me. Okay, so